Have you ever hopped in your car, turned the key, and just gone? That simple twist of your wrist unleashes an incredible symphony of controlled explosions that propels you down the road. But how does it actually work today? We're diving deep under the hood to demystify the heart of your car, the internal combustion engine. By the end of this video, you'll understand exactly what's happening when you press that gas pedal. So, let's start with the basics. Most cars on the road today use what's called a four-stroke internal combustion engine. The name sounds complicated, but the concept is surprisingly elegant. It's all about converting the chemical energy stored in fuel into mechanical energy, the force that turns your wheels. Imagine it like a tiny, powerful power plant, repeating a cycle thousands of times every minute. This cycle, the four strokes, is the key. They are intake, compression, combustion, also called power, and exhaust. These four steps happen inside the engine's cylinders. Think of a cylinder as a chamber, and inside it is a piston that moves up and down. This up and down motion is what we need to eventually create rotational motion to power the car. Let's break down the first stroke, intake. The piston starts at the top of the cylinder and moves downward. As it does, an intake valve opens, and a precise mixture of air and gasoline is sucked into the cylinder. This fuel-air mixture is the lifeblood of the engine. Getting the ratio just right is crucial for efficiency and power. Once the cylinder is filled, the intake valve closes, sealing the chamber. Next up is the second stroke, compression, with both the intake and exhaust valves now closed. The piston reverses direction and moves back up the cylinder. This squeezes the air-fuel mixture into a much smaller space. Why do we do this? Compressing the mixture makes the subsequent explosion much more powerful. Think of it like compressing a spring. The more you squeeze it, the more energy it releases when you let it go. Now for the fun part. The third stroke of combustion, or the power stroke. At the very peak of the piston's upward movement, when the mixture is most compressed, the spark plug comes into play. It ignites, creating a tiny, powerful spark that explodes the compressed air-fuel mixture. This explosion forces the piston back down the cylinder with incredible force. This is the stroke that actually generates the power to move your car. All the other strokes are just setting the stage for this one moment. Finally, we have the fourth stroke, exhaust. After the explosion, the cylinder is full of burnt gases. We need to get rid of them to make way for the next cycle. So, as the piston moves back up the cylinder one more time, the exhaust valve opens. The piston pushes all the waste gases out of the cylinder, through the exhaust system, and out the tailpipe of your car. Once the piston reaches the top, the exhaust valve closes, the intake valve opens, and the whole four-stroke cycle begins all over again. So, we have this piston moving up and down, but how does that make the wheels turn? This is where the crankshaft comes in. The piston is connected to the crankshaft by a connecting rod. The crankshaft is a specially designed shaft that converts the linear, up and down motion of the pistons into rotational motion. It works a bit like how your legs pedal a bicycle. Your legs move up and down, but they turn the crank, which spins the wheels. Now, your car's engine doesn't have just one cylinder. Most modern cars have 4, 6, or even 8 cylinders, all working together in a coordinated dance. They don't all fire at the same time. Instead, their power strokes are timed to occur one after another, creating a smooth, continuous flow of power to the crankshaft. This smooth rotation is then sent through the transmission, which adjusts the power and speed before it finally reaches the wheels. Let's talk a bit more about the essential supporting systems that make all this possible. The fuel system is responsible for delivering a precise amount of gasoline from your tank to the cylinders. The ignition system, with its spark plugs, is what triggers the combustion. The cooling system, usually with a radiator and coolant, is vital to prevent the engine from overheating from all those thousands of explosions happening every minute. And the lubrication system, using engine oil, keeps all the moving parts, the pistons, the crankshaft, everything gliding smoothly against each other, reducing friction and wear. So when you're sitting at a red light and your engine is idling, this entire four-stroke process is happening at a relatively relaxed pace, maybe around 800 times per minute. But when you hit the gas to merge onto the highway, you're telling the engine you need more power. The engine responds by drawing in more air and fuel for each intake stroke, causing more powerful explosions and making the whole cycle happen much faster, thousands of times per minute. This increases the speed of the crankshaft's rotation, sending more power to your wheels and accelerating your car. It's truly an amazing piece of engineering that has powered our world for over a century, from the simple act of turning a key to the complex, high-speed ballet of pistons, valves, and sparks. The internal combustion engine is a testament to human ingenuity. It takes a simple chemical reaction and turns it into the freedom of the open road. And there you have it, a complete journey from a drop of fuel to a spinning wheel. The next time you're driving, you'll know exactly what's happening under the hood. It's not magic. It's just brilliant engineering. I hope this helped you understand the inner workings of your car a little better. If you found this explanation helpful, please give this video a thumbs up. Let me know in the comments what other car topics you'd like me to break down. And don't forget to subscribe and hit that notification bell so you don't miss our next deep dive. Thanks for watching, and drive safe.